In the second paragraph containing question number 14 and 15, it is given that consider an infinite grid of hexagonal cells. Resistance of each branch is R. Points PQR are indicated in the grid. So in question number 14, if battery of EMF E0 and internal resistance R is connected between points P and Q, then power delivered by the battery is equal to. So let's, first of all, we have to calculate what is the equivalent resistance of this grid about point P and Q. So in order to calculate this, let at point P, let I current is coming from the external source, then I by 3 current goes in this way, I by 3 current goes in this way, and I by 3 current goes in this fashion. At point Q, let I current gets collected from the grid and it goes back to the external source. So I by 3 current comes from this way, I by 3 current comes from this way, and I by 3 current comes from this way. So if I apply the principle of superposition, then net current in this branch is 2I by 3. So the net current in this branch is 2I by 3. So if I replace this infinite grid with a single resistance, then I can write this is the R equivalent 2R by 3. This is the battery of EMF E0 and its internal resistance is small r, and this is the circuit about point P and Q. So in order to calculate the power delivered by the battery, first of all I have to calculate what is the current through the battery, and the current through the battery is E0 divided by total resistance, and the total resistance can be written as 5R by 3. So the power delivered by the battery is E0 into I. So if I substitute the value of E0, then it comes out to be 3 by 5 E0 square by R. So option B is the correct answer. Let's move to question number 15. In question number 15, what should be the internal resistance of a battery so that when connected between points P and R, then power delivered in the grid is maximum? So first of all, we have to calculate what is the equivalent resistance of this grid about point P and R. So in order to understand this, let I current from the external source get distributed at point P. Then I by 3 current goes in this way, I by 3 current goes in this way, and I by 3 current goes in this way. At point Q, this current gets further divided. I by 6 goes in this way, I by 6 here. At point R, it gets further divided, I by 12 and I by 12. Similarly, suppose this is point P, this is point Q, this is point R. If I current gets collected from the infinite circuit to goes back to the external source, then I by 3 come from this way, I by 3 come from this way, and I by 3 come from this way. Here at this junction, I by 3 current goes in this way, so I by 6 comes from here and I by 6 comes from here. So if I calculate what is the net current from P to R, then net current from P to R, suppose this is P, this is Q, this is R, then from here to here, if I apply the principle of superposition, then it is I by 2, and from here to here it is also I by 2. If I apply an ideal battery of potential difference V between P and R, then I can write I by 2 into R plus I by 2 into R is equal to V, or R is equal to V by I, that is the R equivalent of this infinite grid about point P and R. Now it is asked in the question, what should be the internal resistance of a battery so that when connected between points P and R, then power delivered in the grid is maximum? So from maximum power transfer theorem, we can say that when the internal resistance of battery is equal to the resistance of external load, then the maximum power is delivered in the load resistance. So if I represent the internal resistance of the battery by R dash, then R dash is equal to the load resistance, that is R in this case. So option D is the correct answer. So the correct answer for question number 14 is option B, and for question number 15 it is option D. Let's move to question number 16.